Next up, it is Jeff Tranter from Integrated Computer Systems, who will entertain us for a short while about the Internet of Things and what it is, and why should somebody care?
Hey, thank you, and good afternoon, everyone. I'm Jeff Tranter. I'm a consulting manager at ICS, where we work on a lot of different projects, mostly related to Qt. There's been a lot of focus in the last while on the so-called IoT, or Internet of Things. I think some of that was reflected in some of the keynotes this morning. I thought there might be interest in a kind of a general talk on what the IoT is, what it's about, some of the buzzwords, some of the technology. So I'll try and give you an overview of that today. First, a little aside. Some of you may know a lot of the protocol standards on the internet are defined by things called RFCs, going back quite a few years. And there's kind of a tradition to publish a joke RFC on April Fool's Day. And there was one way back in 1988 that talked about a protocol called Hypertext Coffeepot Control Protocol. And this was a proposed standard for controlling coffee pots and coffee makers on the internet. So back in 1998, this was considered a joke, something that was funny, that the idea that somebody would put something like a coffee machine on the internet. They even imagined in the standard that this might cause problems with running out of address spaces on the internet, something that's actually happened recently. So it's kind of funny that this was considered a joke in 1998, and this has become reality in the last couple of years. So what exactly is the IoT? I'll talk a little bit about what it is not, a bit of terminology, some of the terms, talk about some examples of things that could be considered IoT products, some of the marketing predictions on where the growth, what the growth is expected, and some of the market areas. Talk a little bit about what it means to software developers and some of the embedded platforms that are popular, and a little bit on some of the key protocols. And I'll try and tie this in a little bit with Qt and talk about some of the relevance to Qt today and in the future, and some of the challenges that we're going to see with IoT. So if there's time, I may have time for a few questions. We'll see. We'll start off with a few definitions. There's many different definitions, but depending on where you go to. This one came from Wikipedia. That's pretty good. I'll let you maybe try and read some of that as I'm talking. But really, IoT is about devices on the internet that collect information. It includes the embedded devices that may be things like sensors. Includes connecting them to different types of servers on the internet with various protocols, and then doing things with this information. As we'll see, there's a number of predictions about growth. The one here on Wikipedia was talking about seeing 50 billion connected devices by 2020. Now, this is the North American usage of a billion, where it's 1,000 million. A couple other definitions, maybe more of a marketing one. This one comes from Cisco, where they actually prefer the term Internet of Everything and talk about kind of high-level bringing together people and data, bringing information together, making it relevant to people, kind of a marketing person's view of things. To an engineer, you can think of it maybe as bringing together, decreasing hardware costs through things like Moore's Law, constantly decreasing costs of connecting to the internet and getting higher speed bandwidth. Basically, that coming together means that the cost to connect something to the internet is becoming very small. It's becoming feasible to put a processor in just about anything and connect it to the internet. So the term IoT, or Internet of Things, was coined by somebody in 1999. There's a bunch of buzzwords and catchphrases. One is anything that can be connected will be connected. The scope really consists of a few main areas. There's the actual embedded devices that collect data of some type from things like sensors. There's usually some kind of data storage, you might call it cloud storage, and then a process of analyzing all this data and trying to find useful information. Could be called aggregation or analysis. And then finally, some type of applications that will present the data to end users in some kind of meaningful way. So really this brings together kind of what you could call a perfect storm of really low-cost hardware sensors, low-cost computing, where processors are getting down to less than $1 in cost, extremely small, plus the low cost of being able to connect to the internet and low-cost cloud storage. So that's really coming together to make all of this feasible. So a number of companies, big companies like IBM, Google, we'll see a graph shortly, see a huge opportunity here, and they want to get a piece of the pie and are trying to align themselves to pick up different pieces of all of the Internet of Things. So IoT is often used as the acronym for Internet of Things. You may hear Internet of Everything. Generally, that's the same, just another term for the same thing. Some companies like Cisco like to use Internet of Everything. You may hear reference to Web of Things, which can talk a little bit more about software architectures for connecting things to the web, sort of an application layer. There's a lot of buzzwords like smart grid, where the electrical grid is being used using sensors and the internet in a more automated fashion and more smart fashion. You may hear of cities saying that they want to become smart cities, where they make use of digital technologies for collecting information to help provide services, reduce cost. There's some new classes of hardware, things like beacons, which use Bluetooth Low Energy to detect the presence of devices, can detect, say, a person entering a store, provide some information to them. Another one is wearable computers, where now there's devices that are meant to actually be worn on clothing, can be sewn inside clothing. There's specialized embedded computers that can actually be sewn into clothing and are washable. So briefly, maybe look at a few examples of things that you might call Internet of Things. And depending on where you live, some of these may be quite commonplace now, or some of these may be a little more modern, but these are things that exist today. Things like on the upper left there, a smart trash can that can detect when it's full and alert trash collectors that when it needs to be emptied. On the upper right, one of the common home thermostats, where you can get information about temperature and climate control over the internet, control your thermostat. I know where I live, the power company has encouraged people to use smart thermostats that they provide, and they can actually take control of your heating or air conditioning in the event of a power shortage. Usually if there's a shortage during the summer, they can cycle off air conditioning. On the left there, a new class of devices that are fitness devices that could have things like heart rate sensors, detect motion, that are wearable and can provide that information to other devices like your smartphone. The coffee maker there, referencing back to one of the first slides, there are coffee makers now that are controllable over the internet, over a home network. Appliances like washing machines, refrigerators are starting to have connectivity. The bottom right there is something called the Fly Nixie, which was a crowdfunding project to develop a wearable computer that's also a quadcopter that can fly. Other examples on the left there, farms are using biochips in farm animals to track them and monitor their health. IVI, we saw a lot of discussion of that today in some of the booths and the talks today. Parking meters is pretty common now. You can pay your parking meter through a smartphone or other device. Soft drink machines, home control and security. There's even Wi-Fi enabled light bulbs now, where there's hardware built into a light bulb to allow you to remotely control a light and get information on its status remotely through the internet. The bottom right was an actual crowd-funded project to develop an IoT-connected toothbrush, and that's a real product now. So look a little bit at some of the growth projections. The different numbers come from different sources. I'll just show a few graphs here. This is from the Gartner group. They're talking about the the breakdown of the number of devices over the next few years, and they're predicting about 26 billion internet-connected devices by the year 2020. And actually, the number of mobile devices exceeded the number of human beings on Earth last year in October of 2014. So there's already more smartphones or mobile phones than human beings. This is another one showing some other growth projections. This is from the hardware side, projected semiconductor revenue over time and how it's broken down. And you can see kind of a trend there that the pieces are not too different, but consumer products are expected to be the largest, and then automotive and industrial. This shows some of the companies that are investing in IoT, and not too many surprises here, but the top ones tend to be well-known companies like IBM, Google, Intel, Microsoft. They're spending a lot of money to try and position themselves to have a piece of the IoT future. And so what does it really mean more to software developers and engineers, which is probably most of this crowd? Based on these growth projections, there's some huge opportunities for software development, similar to the shift I think some of us saw who've been using Qt for a number of years, where it was initially more of a desktop platform, and then we saw a shift to mobile, and now a shift to embedded and tablets. I think we're going to see a similar shift of a lot of development being done on IoT, and that includes the low-level embedded devices. It includes the cloud storage area, the aggregation and data analysis side of things, and then actual applications that end users will run. So we'll talk a bit about some of the common hardware platforms. These are like sort of off-the-shelf things that can be used for the low-level talking to sensors and things like that. So you have things like the Arduino in the upper left. That's a very low-cost hardware and software platform using an Atmel AVR microcontroller. Some of them use ARM processors. It's a family of products, and there's a really short learning curve for these. It's really easy to get one of these things up and running and talking to different sensors. A few years ago, it was typically quite an effort to get some kind of embedded system to get to the point running maybe its first Hello World type program where you do something like flash an LED, but today it's very easy with something like an Arduino. That's sort of on the low end. It isn't running a real operating system. Then you have things like the Raspberry Pi in the middle there that is $35 computer, credit card size. It's running full Linux distribution with a GPU, decent amount of memory. The latest one's got a 4-core ARM CPU, so it's pretty powerful. Other ones on the bottom left, the BeagleBone Black is one that comes from Texas Instruments and can run different operating systems like Linux and Android. The bottom right is Intel's Galileo, which has an x86 type architecture and generally runs something like a Yocto flavor of Linux. The one on the right is the Intel Edison. That's a version designed for wearable computers. So these are off-the-shelf devices. If we're going to build some kind of high-volume commercial product, you might start with one of these, and then you probably design your own custom hardware, custom board. Look briefly at some of the protocols that are relevant to the IoT that are starting to appear. One of them is called COAP, or Constrained Application Protocol. This is a standard that's been defined for a protocol to the low-level devices. It's defined as an RFC standard, targeted at low-power sensors and things like that, and it's based on some other standard protocols, things like REST, using Ethernet networking. There's a number of implementations of this, so if you wanted to use this in an application, you could probably find a suitable open source or commercial library. There's things like the Cant COAP library, which has C and C++ bindings that you could easily use on something like an embedded Linux. Another standard is something called MRAW. This is kind of standardizing how you could do low-level communication with things like GPIO pins, protocols and buses like I2C, SPI. This is sort of similar level to what you might do on something like a Raspberry Pi or an Arduino, but those tend to be different on every platform. So the idea of this is standardizing the low-level API so that you could write something that would be portable and run on, say, a Raspberry Pi or a BeagleBone or an Intel Edison with the same code. So part of the idea of this is to make it easier for hardware manufacturers of things like sensors to support their devices on different platforms. And since this is a developers conference, I thought I had to show some code. So I've got one slide here with a little bit of C code showing an example for this Emre protocol. So this would be kind of the level that you're working on. This would be something that just toggles a GPIO pin to do something like flash and LED. And they provide C and C++ APIs to do this. This is a lot like what you'd be doing if you're programming an Arduino, but this is portable to a number of different platforms. If you're working at a higher level protocol, like something like I2C, you could work a little bit higher level, or if you were using something like a temperature or humidity sensor, then there's code that you could use that would directly give you things like a temperature reading. Some other technologies, you might have heard of Bluetooth Low Energy, which is a new extension to Bluetooth designed for the embedded devices, used a lot on low power devices, so it's really aimed at being able to support Bluetooth on something that is low power, typically running on batteries. Things like the fitness bracelets. On the upper left there you see a quadcopter. That's something that's controlled by Bluetooth Low Energy and is controlled using a smartphone. Let's see, another protocol is the Oma Lw M2m Protocol. That's another protocol that defines sort of the application layer that you can use for IoT. And this is frequently used in conjunction with the COPE protocol that I mentioned earlier. So this, I think, is a pretty comprehensive standard and covers a whole bunch of things that I list here, like device management, server controls, access, connectivity, things like that, firmware updates. So I'll look also at a few of the operating system platforms that are suitable for IoT. So Microsoft has come out with actually a family of versions of Windows 10 aimed at IoT, and one of them is called Windows 10 IoT Core. This one is kind of relevant for people using things like Raspberry Pi hardware because it'll run on the Raspberry Pi 2, it'll run on the Minnow boards. And this is a version of Windows 10 for IoT devices. It's got some support for talking to Arduinos, and it's basically a non-GUI application that would tend to be run headless without a GUI and be talking to hardware. It's actually part of a family of what will be a family of Windows 10 IoT devices. So there will be one targeted at mobile devices and one for industrial devices. So this is something that's available now for free for people who want to look at it and run it on some of the low-cost hardware. It's still kind of unclear whether whether this is going to be one of the major players for IoT or not. Linux is probably the most popular embedded platform. On the real low end, on things like Arduinos, Linux may not be suitable for really low-end hardware where you don't have the ability to run a full operating system with a file system and things like that. It also may not be ideal if you need some hard real-time or deterministic requirements where you may want to use an RTOS, but it's often a good fit for IoT-type applications. And we're starting to see distributions of Linux specifically targeting IoT. So for example, Ubuntu has snappy Ubuntu Core, which is targeted at IoT devices. There's also frameworks for helping you put together your own embedded Linux distribution so you don't have to start from scratch, things like Yocto. And obviously Linux is also popular on the server side for implementing things like cloud computing and data aggregation. So let's see if I can tie some of this into Qt. today, at least, Qt is generally too heavy to run on the real low-end hardware, something like an Arduino, where you're not running an operating system like Linux. So it's not really suitable at the real bottom end, but that may change in future. But it can certainly run on some of the more powerful but still really low-cost hardware like a Raspberry Pi. Probably its best strengths would be UX. It's always been kind of a strong area of Qt and server-type applications. So some of the advantages of Qt for this is you've got good performance because you're working in a compiled high-level language if you're using C++. You've got the cross-platform advantages of running on a whole bunch of different platforms. And Qt does have some lower-level APIs that you may want to use for IoT for actually talking to devices. So things like the networking classes, serial, Bluetooth Low Energy has been supported now on a number of platforms. And looking to the future, it looks like there's going to be some additional modules that support more protocols. So Qt 5.6 is going to include a new Qt serial bus module that's going to add support initially for a couple common buses, CAN bus and Modbus, and that's going to be a tech preview in Qt 5.6. And we'll probably see more protocols supported in future by this module or other modules. So what are some of the challenges of IoT? There's a number of technical challenges and non-technical ones. Privacy is one that's a big concern because there's a huge amount of information that's being collected relevant to people, whether it's from body sensors, location information. That's certainly an issue, and I think it's going to be an increasingly important issue on how that information gets used and how it's protected. Most companies now, or most countries have starting to have pretty strict privacy laws, and probably have to extend these to cover IoT. So that fits into security and safety as well. People have probably heard of some of the well-publicized cases, like being able to remotely start controlling an automobile through the internet because of various security issues or software bugs. Another issue is just going to be scaling things up. The huge amount of data that has to be stored and the number of IP addresses. We've actually, in most countries now, actually run out of the IPv4 address space. The IP version 4 supports about 4.3 billion addresses, and most of those have now been allocated in most countries in the last year or two. I think in the United States they've basically just run out in the last couple of weeks. So the solution to that is IPv6, and people are moving to that. That's going to support a ridiculously high number of unique devices, something like 10 to the 38. So the migration to IPv6 is happening, but it looks like it's happening at a rate of about 4% per year, so it's not happening too quickly. Data storage, as you can imagine, huge amounts of data being collected from all these sensors. The storage industry needs to accommodate how to do that and deal with the impact on all the bandwidth of the data that's going to do that. Some databases were designed with certain kind of use models or use cases, and they may no longer be accurate for IoT-type applications and may require changing the way data is stored. There's even the environmental impact with all of electronics that's having a shorter and shorter lifetime. Typically in the United States, people replace their cell phone every 2 years on average, and the number is going down. I know Apple recently introduced a subscription plan where you could automatically receive the latest iPhone whenever it comes out. So wrapping things up, I think the question is, it's not whether IoT will be big, but it's just a question of how large and what the timeframes will be, and most of the analysts are agreed pretty much that this is on a huge growth phase, and we're on track with some of the graphs that they showed. As I mentioned, it's going to provide a lot of opportunities for people in the software and hardware business, and a number of challenges, whether it's technical challenges or challenges related to privacy and security. If we go back to that first slide that I mentioned for the Hypertext Coffeepot protocol, which was a joke back in 1988, somebody revised that in April of 2014 to add a new standard to support brewing tea on the internet. And actually, the original protocol had defined an error 418 that was it would be returned if a coffee maker was requested to make tea. So that this new protocol is going to address that. So that took 17 years to go from the coffee maker to having support for tea. So as always with these challenges and the growth that's predicted, it's going to be kind of the way it's always been in the software industry. We're living in interesting times, and it looks like there's going to be lots of challenges in workforce in the future. So there were a number of references that I mentioned with footnotes or superscripts in my talk, and the slides should be available online at the conference site eventually. So I've listed some references here that you should be able to pick up later on the conference site, some of the things that I found useful related to IoT. So I think I've got 2 or 3 minutes left to maybe take a few questions before we wrap things up.
On a Raspberry Pi last year, I tried last year to do some QML on a Raspberry Pi with Raspbian, but I only found Qt4.8 on it. Did it get better? Or?
Well, Qt4 was officially packaged for the Raspberry Pi. Qt5 is still not officially packaged for the Raspberry Pi, but it is quite a bit easier to build. It basically builds out of the box from source. And there's some instructions around. I think you could start with the wiki on the Qt website. So you basically have to build it yourself, but it pretty much builds out of the box.
How long does it take?
Well, you can cross-compile it, but actually with Raspberry Pi 2, you can build it natively. But you're still probably talking a day to build everything and the demos, but which is still better than the Raspberry Pi 1.
I do think we have to say thank you to Jeff for this, and we'll be back in just 1 or 2 minutes with a bit more about the Internet of Things. Thank you.
Okay, thank you.